Okay, so in this video, I'm going to show you how to multiply and divide rational expressions. So let's take a look at what a rational, well, we already know what rational expressions look like. It's like a polynomial over a polynomial, like a fraction, but just with rational expressions in the numerator and denominator. And we're going to be multiplying them. So let's start off with some monomial rational expressions. 6 over a squared times negative 2 over a cubed. Basically, just like with regular fractions, we multiply the numerators and we multiply the denominators straight across. And as a result, we get negative 12 over a cubed. And as I noted down here at the bottom, always look for factors common to the numerator and denominator to divide out. Basically, kind of like reducing the fraction. So here we have 12, and so basically numbers at the top and variables at the bottom, so they don't have any common factors. So this would be our answer. Let's look at a second example with binomials in the rational expression. And once again, we multiply the numerators and the denominators together straight across, and we get x, the product of x minus 5 times x minus 7 on the top, and on the bottom x times x plus 3. Just notice I just moved the x in the front because that's just the standard form right there. But there are no common factors, so this is our final answer. Okay, so now in this slide, you can pause the video and you try. Did you get these as your answers? If so, great job, and move on to the next. If not, go back, check your steps, and see where you might have made a mistake. Okay, in this next example, I'm going to show you how to multiply and divide, or multiply rational expressions by using factoring as one of the steps. So here we have two rational expressions being multiplied, and in the second expression, I have a polynomial that is able to be factored out by using the GCF. So here we're going to use the GCF, and this one is a difference of squares. Difference of squares. So if you don't remember though, go back and look at what that means. But here are the results of factoring them. Okay, so I factored out a negative 8. Hold on, let me change that real quick. Okay, so I had to fix the sign here. When I divided out a negative 8 from here, this becomes a positive because a negative 8 times a positive 2 will give me that negative 16. Okay, so I factored out the top by using my GCF of negative 8. And down here, like I said, this was a difference of two squares, so it factors out into a product of two binomials with opposite signs, x minus 2 times x plus 2. So as this has been saying, always look for common factors in the numerator and denominator. Well, this has a whole factor of x plus 2, so that means that x plus 2 and this x plus 2 can cancel out. Because it's in the numerator and denominator, and here we have an x minus 2 and an x minus 2 in the numerator denominator, and they cancel out. And remember, when they cancel out, they equal 1. So all these became a factor of 1. We also have a common factor of 8 that can cancel out, so the 8's cancel out. So I got like negative 1 at the top right there. And so once all the factors are divided out or canceled out, now I can just go ahead and multiply the numerator times the numerator and denominator times the denominator, getting me -1 over x. Okay, so now, sorry. Well, I apologize. I thought I created a slide for you to try the previous example, but I guess you'll just have to wait and use that later. So right now I'm going to show you multiplying a rational expression by a polynomial. So it's kind of be the same, but with a little difference. So here we go. So here we have our rational expression, 3 over c times the quantity c cubed minus c. So of course we're going to make this polynomial over here, this factor right here, we're going to make that into a fraction, or put it in fraction form. So basically put that over 1, you know. And I also went ahead and factored. So I did 2 steps at a time. I factored the c cubed minus c by a common factor of c, and also wrote it over 1 so that it can be a fraction times a fraction. Okay, so we see that we have a factor of c in common, and it's these c's that are in common because they're factors. We cannot cancel out terms, things that are connected by addition and subtraction. I saw that in the last section, but make sure you're only canceling out factors, not terms. The resulting answer will be 3 times, oh, where did that come from? Oh yeah, this c squared minus 1 is a difference of 2 squares. Difference of 2 squares. So that also factors out into a product of 2 binomials with opposite signs, because c squared is a square, 1 is a square, and we have the opposite signs here. So this is our answer there. Okay, here's a second example that's a little more involved. So I see that I do have something to factor here, this polynomial. I'm going to factor that into a product of 2 binomials, and also put it over 1. So here it's nice and factored out. I haven't multiplied anything yet. I just factored first, and I'm looking to see if there are any common factors, and yes, again, the v plus 3 are common, and they cancel out and become 1, and we're left with these factors at the top and only 1 at the bottom. So our answer will no longer look like a fraction, but it'd be an expression 2v times the quantity v minus 5. Okay, so now this is the time when you have examples to try. So go ahead and pause it, work it out, and then unpause it and see if you got the right answer. So did you get these as your answers? If so, great job. If not, go back, look at your steps, look at the steps that I did, and see if you could find where you made your mistakes, or came across something that just didn't work. Okay? All right, let's go to the next one. Dividing rational expressions. Oh, something popped up already. Forgot that animation there, but ignore that at the bottom until we get to it. Don't worry, it'll come. Here we go. Here's our first example in green. We have a rational expression divided by another rational expression. And by rule of dividing fractions, we actually rewrite it as multiplying by the reciprocal. So we're going to take the reciprocal of this fraction, and also take this division and change that into multiplication. So it's going to be rewritten and look like this. We have a couple polynomials that can be divided, factored. So we're going to factor this trinomial into a product of 2 binomials, and factor this difference of two squares into a product of two binomials as well. So here is our results. Now let's go ahead and look for common factors. Do we have any common factors? Yes, we do. A plus 5 in the numerator and a plus 5 in the denominator over here. A minus 6 right here in the denominator. A minus 6 up here in the numerator. And nothing else. It's all over 1. So our answer is not going to be in a fraction. It's just going to be an expression of a product of two binomials, a plus 2 times a plus 6. So let's see a second example. Here we go, our second example. We're dividing by just a polynomial this time. But just like we did before, since this is fractions or in a ratio form, we're going to multiply. We're going to multiply by the reciprocal of this polynomial. And there it is. It's been here for a little while, right there. But here is what it looks like. We just multiply times 1 over 5x squared plus 5x. And we can factor both of these. This trinomial will be factored into the product of these two binomials. And this polynomial down here just has a common factor of 5x, so a GCF of 5x that factored out to give us 5x times x plus 1. We check to see common factors, which I see we have a x plus 1 in the numerator and x plus 1 in the denominator, and nothing else in common. Because remember, we cannot cancel this x with that x, because this x is a factor being multiplied. This x is a term that's being added with that too. So we cannot cancel those out. And so as a result, we get our answer, x plus 2 over 20x squared. So now it's your turn to try two examples of dividing with polynomials. So go ahead and pause it, work it out, and see what you get. Did you get these as your answers? If so, great job, awesome, you're doing great, you're ready to move on. Here are some practice problems for you to do if you're from my class, of course. This is from the textbook, 537, number 1 through 27 odd. So good luck, and I hope this helped.